today we're going to look at sort of the basics of combining like terms. We've talked about what like terms are. Now we're going to talk about how some other things that you can do with like terms and how that's going to make your life in algebra easier. So the first thing I want you to do is, there are two expressions here, and in both of the expressions, m equals 5 and r equals 3. I would like for you to evaluate each of those expressions. I want you to take a moment to pause the video, evaluate each of those expressions. Okay, now that you've done that, you should see you have gotten 48 for each of those. 48 for the one on the left, 48 for the one on the right. If you didn't, look back through your work and see where your mistake was. Now you might notice that after I wrote all the multiplications out, when I wrote the problem in the first line here, you might notice that I went ahead and I did all of those multiplications here because at the same time I was going to join them in separate steps, which you might have done. The reason I did them at the same time was because since they're all separated by addition and subtraction signs, I would have to do those multiplications anyway before I could add or subtract. So I just went ahead and did them all in the same line and saved a couple steps. If you're okay with that, great. If you're not, do them one at a time. That's okay too. So we're going to come back to this at the end so that you can understand why what we're learning today is important. So we're going to talk about combining like terms and how it makes expressions easier to evaluate. And so the first one we're looking at is 5x plus 3x. Now I want you to think about this for a minute. 5x, what it really means is I have x 5 times. So if I have x 5 times, that means I have x, 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 and x. I have x 5 times. And if I have 3x, that means I have x 3 times. So x 5 times plus x 3 times, what you're going to notice is, what that really means is, I have 8 x's because I have x 8 times. And some of you might be saying, whoa, 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 why in the world can we do that? Well, let's talk about that for a minute. You can do that because, let's say I choose a value for x. It doesn't matter what I choose, but let's choose something that's easy to work with because that makes it easier. So let's say that x is 2. If x is 2, then 5x plus 3x is 5 times 2 plus 3 times 2. What 5 times 2 is 10, 3 times 2 is 6, 10 plus 6 is 16. If I look at 8x, if x is 2, then I have 8 times 2, which is 16. Notice I get the same answer either way. I get the same value either way. So when I combine like terms, I get the same answer as if I hadn't combined like terms, and it doesn't matter what value of x I choose for that, that's going to be true. Let's say that I choose, let's say I choose 6. So I have 5 times 6 plus 3 times 6. 5 times 6 is 30. 3 times 6 is 18. 30 plus 18 is 48. 8 times 6 is also 48. So either way, I get the same answer. And I could choose any value of x. It doesn't matter if it's a positive, a negative, a fraction, a decimal. It doesn't matter what value I choose for x. It's always going to be true that 5x plus 3x is going to be equal to the same thing I would get if I just simplified it and made it 8x and evaluated that way. That's why we combine like terms. Let's look at a few more examples. So 4w plus 6h plus h plus 8w. This is a little more complex because we have some like terms and some that are not like. So the first thing we really need to think about doing is grouping our like terms. So I can group 4y, or 4w rather, plus 8w. Now notice something here. Something you can do is you can kind of make a code, if you will, before you even start, to group your like terms. So 4w, notice that the plus symbol goes with the 8w. Because we have 4w, we are adding 8w's. So 4w plus 8w, and then I have plus 6h plus h. So I can bring those down here to join the party. And you might be saying, well, plus h. Well, plus h, well, that's really 1h. So now when I go and I want to simplify this, I could say, well, the 4w plus the 8w is going to give me 12w. And then the plus 6h plus 1h gives me plus 7h. So this one simplifies to 12w plus 7h. And if you don't believe me, go back and choose some values for w and choose some values for h and solve it with the expression on your left, the expression on your right, and you're going to see that you get the same value either way that you do it. You also do need to be sure, as I kind of stated, to pay attention to whether you're adding or subtracting. So when you look at this, my first term here is 5x. There are no others like the 5x. Then I have plus 6y minus 2y. And I have plus 9 minus 4. It's really important to note that the operation symbols go before the term. So your term needs to keep the operation symbol that's before it when you rewrite, when you group. So I'm going to have 5x plus 6y minus 2y plus 9 minus 4. So the 5x, again, it can't combine with anything else. I'm just going to keep it 5x plus, well, I know it's going to be plus, but let's look at y. It's plus 6y minus 2y. So if I have 6y, think about plus as I have 6y, minus means I need to take away. So if I have 6y and I take away 2y, I still have 4y. So 5x plus 4y. And then last but not least, a plus 9 minus 4. I have 9, I take away 4, I still have 5. So it's a plus 5. So 5x plus 4y plus 5 is what I get when I simplify that. Another example. 5x plus 5q minus 3 plus 3x. I can group the 5x plus the 3x, and the others don't really have another term like them. So I have a plus 3q, or plus 5q rather, and a minus 3. So I end up, once I've grouped my terms, I end up with 5x plus 3x plus 5q minus 3. So now when I combine them, 5x plus 3x is 8x, and then I can't do anything with the 5q, so I just keep the plus 5q, so I keep it. I can't do anything with the minus 3, so I keep it the way it is. There's nothing else there I can combine. Looking at a couple more examples, 4a plus 3z minus 2z plus a. I can, of course, combine 4a plus a, and then plus 3z minus 2z. So when I now rewrite to group 4a plus a, and remember that's going to be how many a's? That's going to be 1a plus 3z minus 2z. So 4a plus 1a is 5a, and then plus 3z minus 2z, I have 3z, I need to take away 2z. So that means I still have, which is going to be an addition because I still have it, plus z. I have 1z, and I can just make that z because the 1 doesn't change the value. Look at one last example together, and then you can do some on your own. So 7y minus 2y, then plus 3y squared plus y squared plus 16. So that, when I rewrite it, leaves me with 7y minus 2y plus 3y squared plus y squared plus 16. So 7y minus 2y is 5y. If I have 7 and I take 2 away, that leaves me with 5y. And then plus 3y squared plus y squared. Sometimes people get a little confused about that because of the exponent up here. It doesn't change anything. We still do the same thing. We add the coefficients. The variable and exponent stay the same. So then remember, this is 1y squared. So 3y squared plus 1y squared makes plus 4y squared. And then we have, of course, the plain old plus 16. And that's as simple as we can get. All right, here are some more examples for you to try on your own. So try each of those on paper or whiteboards or what have you. Make sure you pause the video, and when you're done, you can check. So we pause the video, we're trying these. And here are your answers. Once you're done looking back at those and making sure you understand why the answers what they are, let's go back to the very beginning where we started, and let's talk about why is it that combining like terms is helpful? Well, if you will notice, if we were to combine like terms on the expression on the left, 6m minus m plus 5r plus 2r minus 7 minus, or plus 9 rather, we would end up with 6m minus m plus 5r plus 2r minus 7 plus 9. So 6m minus m is 5m, because remember that's a 1m. 5r plus 2r is 7r, and it's going to be a plus because those are both addition. And then minus 7 plus 9, if I have 9 and I need to take away 7, then I'm still going to have, which means plus, I'm still going to have 2. So if you will notice, the expression on the left is equal to the expression on the right, and that is the reason why when you evaluated, both of them gave you the same value. And that's the beauty of simplifying your expression, because it makes the evaluating so much